Hello friends, I Abhinav Negi welcome you all. On 6 January 2004, the construction of Burj Khalifa started. The 828-meter high, the tallest building of world is, yes, the tallest building, but it is 65% more taller than that time's second tallest building. Usually, when this race has started, many centuries before of being the highest building, that time whenever a building is coming in the first position, it is surpassing the second highest building by 1%, 2% or maximum 5%. But the Burj Khalifa is not only aiming for being the highest, but it is aiming for being the highest by far, that is 68%, and for a large amount of time. But yes, for achieving that, lot of sacrifices, challenges have been to civil engineers, which Burj Khalifa has taken and successfully accepted all these challenges. Guys, on 6 January 2004, the construction has started. One of the major challenge there was that soil was not very hard. So this very height 828-meter high building, how it can be supported on loose sand and some sedimentary rocks. Yes, now it is constructed. I'll be telling you all the challenges and how civil engineers have overtook them. But let me tell you, it is that much high that the sunset you can see from the bottom floors, and again on the same day you can see the sunset twice by going to the lift and again seeing the sunset from the top floors. This is so much height that in this whole world there was no pump that can take the concrete from there to there. There is no pump. The pump itself has to be invented that can pump this meter height, 828-meter height. Of course, the Burj Khalifa, they have invested lot of money, but now all those money they are coming, all those sara paisa aa gaya by the tourism and other things. Now coming about the foundation, let me tell you guys, 24/7 the electricity is passing from these 192 piles. Why? I'll tell you later. Friends, why? What is the foundation? The foundation is, of course, the deep foundation, the pile foundation. Why it is deep foundation, pile foundation, I'll tell you. But over 45,000 meter cube of concrete weighing more than 1,10,000 is used to construct those 192 piles. Now, why the pile foundation is done? Because when the excavation is done, when the soil exploration, the soil testing was done there, and they are excavating the soil, then up to 140 meters, no hard stratum was found. Only loose sand and sedimentary rock, over which the so huge building cannot be supported. Okay, ultimately all the loads will be transferred to the soil. If there is a hard stratum, we can put the soil there, but the hard stratum was not present. Only loose sand and sedimentary rock. Sedimentary rock itself is not hard. So what the civil engineers proposed here, that the students who have studied pile foundation may be knowing that these piles are there. Whenever the ultimate load is coming from the top, this QU is resisted by two things, QF plus QP. Of course, here QP will not be much. One is the from here, QP is almost zero, nil, almost nil, because the hard stratum is not there. So nobody is resisting from the bottom. So maximum load we are getting from here, friction. Okay, so this much long piles and large diameter have been made, so this QF is significant. So they are the resisting the load mainly from the friction, because there is no hard stratum to provide the QP. Now the raft, this raft you have seen that this is a buttress shape so that the wind load can be resisted. Now, what is so special about this buttress shape? I will be coming there also. But let me tell you, this thickness of buttress shape is 3.7 meter. Let me tell you, the 3.7 meter height is the height of two adults. if you put two adults one by one, one over the other, the height will be approximately 3.7 meters. So that much height this concrete has been made. And guys, usually the concrete we are making, and then we are doing this vibrator like for compacting the sand, for compacting the concrete. But here, due to the huge deep pile foundation, this cannot be done. So a special type of concrete which is very liquid as compared to the ordinary concrete that you are seeing, that has been used so that it can be compacted naturally. Now the settlement that has been found was 5 centimeter, which was in the permissible limit. After the construction completed, the settlement was there 5 centimeter. See, the 116 stories building, 828-meter high building with tons of load and the settlement is only 5 centimeter. That is only due to the significant value of QF. Foundation took 2 years. Now a very important thing, guys. Apart from the huge dead load, one major challenge in Dubai was that the wind, for this huge building, the wind load will be there. And of course, in Dubai, the sandstorms are also coming of approximately as high as 100 km per hour. Due to these wind loads and sandstorm, this Burj Khalifa may collapse. Now let me tell you, usually what happens, suppose this is a tower and I'm putting the glue exactly at the center. I'm putting the glue exactly at the center. Then with certain load, this can topple. But if I'm not putting the glue exactly at the center, I'm putting the glue at the circumference, at the periphery, then the chances of toppling, it has been observed, has been decreased. Okay, so instead of putting the glue here, we should putting the glue here so that the chances of toppling has been decreased. Same thing the architect Jim Laker has been done here. On the periphery of this buttress structure, guys, more piles have been used. The density of piles is more near the circumference. Okay, density of piles is more near the circumference, and as compared to the periphery, here the density is less. So that just example I have given you now, the more glues at the corner, at the periphery, at the circumference, less chances of toppling due to wind load and sandstorm. So the buttress structure is such made that here there is more density and at the center the density of pile is less. So the more support is near the periphery or the circumference. Now you might be wondering why these piles are carrying the current 24/7. Now this is a concept of current in which I am not going very deep. That happens in battery also, that there is a cathode and anode. Then most of the deterioration of material happens in anode. So these piles have been made cathode, and there we are putting an anode also, and we are flowing the current. So all the electrons and everything is going to the cathode and impurity is sticking to the anode. So these are not getting corroded, but yes, the anode is deteriorating. That is why at certain interval this anode has been replaced with the new one. Why this is done? Because nearby there is Persian Sea. Okay, nearby the Dubai there is a Persian Sea, and the water can come from there, which may deteriorate the piles, which the strength can be reduced due to corrosion, and this can topple. So that is why a current is flowing, so that this is acting like a cathode and all the impurities are going to the anode. Anode will deteriorate, and after some time we will be replacing the anode. One major challenge also apart from this was that when we are excavating for putting the soil there, this is suppose ground level. Okay, this is suppose ground level. When we are excavating, then these excavations may collapse. So while excavating, we are putting the slurry also simultaneously. While excavating, we are putting the slurry also simultaneously. So this slurry is having more density, high density. So this walls, this excavation is not collapsing. Okay, so now the piles, the precast piles are inserted in these holes. Okay, the auger has been used for drilling this. Okay, so this is all about the foundation, guys. The frictional pile is used. Okay, the slurry has been put so that, see guys, the critical height of excavation is this na, 4c by gamma root k. You studied in earth pressure chapter. So this is much more than this critical height. Okay, So that is why a slurry has been also put so that these are not collapsing. Slurry is holding the walls intact. Okay, so these all challenges are made, and that is why the civil engineers are there, for facing all these challenges and overcoming them. Now my question to you that you have to put on the comment section: theoretically, how much height, how much maximum height we can achieve? Is it 1 kilometer, 2 kilometer, 4 kilometer, or 10 kilometer? Please let me know in the comment section. How much theoretically high building, maximum high building we can make? 1 kilometer, 2 kilometer, 4 kilometer, or 10 kilometer? Please like the session and share with your friends. Thank you.